Hello everyone, this is PM Chellapandi here. First of all, I would like to welcome you to my today's session. In this session, we are going to solve this problem by using mathematical induction method, right? Okay, so before we dive into solving this problem, let me have a quick review about this question. So here we have a proposition, okay, which is involving in terms of natural numbers. So here our task is we need to check whether this proposition is true for all the natural number or not, right? So in order to prove that, so we are going to take one of the mathematical method that is called mathematical induction method. So such a problem can be proved by induction method. This is very basic method. So the induction method is nothing but there will be three steps. If we satisfy that three steps for this proposition, then this is true for all the natural number, right? So okay, in step 1 we have to show that the given proposition is true for the value 1, right? So let me check whether this proposition is satisfying for 1 or not. So for that, first you take the nth term in the left hand side, right? So this is equal to right hand side. This is what we want to show that when we substitute n is equal to 1, right? So now left hand side is 2 power n. So I'm going to check whether what is the value for n is equal to 1. Put n is equal to 1 in your left hand side, then you will get 2 power 1 is 2. So let me check whether we are meeting the same value in the right hand side or not. So first write what you have in the right hand side. Now you have to check n is equal to 1 in the right hand side. So whether we are getting the same value or not. So I'm just simplifying. It is 2 power 1 plus 1 is 2 square. It is 4. Then 4 minus 2 is 2. Now look at this one. Here the value for left hand side is 2. At the same time the value for right hand side is also 2. Okay. If we satisfy this condition, then the proposition is true for 1, right? Okay, now we have satisfied the step 1. Let us move to step 2. In step 2 we are going to assume now, okay, we are going to assume the given proposition is true for k, right? We are not going to prove whether the k is true or not. Just we have, instead of proving this, we are going to just assume, because step 3 is very important. If your given proposition is satisfying the step 3, then this is a valid proposition for all the natural number. So okay, now let me come here whether we are satisfying step 3 or not. To satisfy your step 3, you need your step 2, right? So always remember, we have to assume our given proposition is true for k, which means we just have to write the given proposition in terms of k, which means n can be replaced by k. That is your proposition in terms of k. Okay, we just assume this is the equation number 1. Now let us come to step 3. In step 3 we want to show that the given proposition is true for k plus 1, right? So for that, in the first step we need to write the given proposition in terms of k plus 1, which means we have to write the same proposition wherever we have n, that has to be replaced by k plus 1. So in the first step that I have done here. So here what we have to do? So we have to satisfy the left hand side is equal to right hand side, right? So if we are able to satisfy that, then the step 3 is true. If step 3 is true, then our given proposition is true for all the natural number, right? Okay, let me check whether it is satisfying step 3 or not. Okay, now here I'm going to take the left hand side. I'm going to write the left hand side one more time, right? So you should understand one more thing. When you are writing your left hand side, you have to write including the previous term to the last term. That is very important in order to prove the condition, right? So what is the previous term to the last term? Here what is the last term? It is 2 power k plus 1, right? So obviously the previous term is going to be 2 power k. Okay, I tell you later why. I tell you in the next step why we are writing like this. Now here we are going to club from first term to till the before the last term. Now look at this series. It has a result in the previous step, right? The result is 2 plus 2 square plus 2 cube plus etc. 2 power k is going to be this one. Now instead of the whole series, you can substitute this result, right? Now plus 2 power k plus 1. Then here 2 power k plus 1, 2 power k plus 1 is common, right? In here and here. You can take outside in these two terms, then you will get 1 plus 1 minus 2 will be that side, right? Now here, when you add these two, your answer is 2. Now in this case, from this result, we have to show what? We have to show this one. So almost we have got minus 2. We need to adjust our result only in this term. 2 power k plus 1, 2, right? Okay, so here we have 2 power k plus 1 and 2. If we have same base, then we can add the numerator. We can add the power, not numerator, we can add the power. So here 2 and 2, it is base values are same. So we can add the power. So k plus 1, 2 power 1, it is k plus 2, 2 power k plus 2 minus 2. This is what we want to show that. Okay. Now the given proposition is true for p of k plus 1. So dear student, this is very easy sum. You can easily solve this problem if you understand. So I hope you all have understood about this problem.